Hi there, folks. Today we're talking about finding slope and rate of change. And really, we already have a concept of this. That pattern that we've been talking about as we graphed points to form lines, that pattern to getting from one point to the next, that is the slope. So we've already kind of been describing this in terms of a pattern, but now we're going to look to this as kind of its own thing and describe it as a ratio. All right. So slope is a ratio of a vertical change to a horizontal change. There are three ways that we can think about slope. The first one is rise over run, and this is visually what we see when we're looking at a graph. All right. The second one is an actual mathematical formula that will give us the slope, that will give us that pattern, that rate of change. And this one is typically used when we're given points, all right? So when we have two ordered pairs, we can plug them into this formula and use that from there. And then the last one, that little triangle means change. That's delta, all right? And in science, you'll sometimes see that, but that's change in y over change in x. That last one is kind of the go-to that kind of is the bridges the gap between these two. So really that one works okay when you're looking at the graph, but it also works okay when you're looking at points. And that's the one that we kind of think of it more in terms of rate of change, the change in y over the change in x. And so that one's a little bit more universal. It kind of allows us to think of it in both ways, all right? For example, if I look at something like this guy, here I'm given a graph, and so the best thing to do is rise over run. And it's really important that we do the up and down motion over the left and right motion. And when we're doing the equation, it's the same thing. It's the change in y over the change in x. It's subtracting the y's over subtracting the x. It's always the vertical stuff over the horizontal stuff. But for this one, I just have to identify points that this thing goes through. And it looks like it goes through this point, this point, this point, this point. And really, it's just a matter, when you talk about rise over run, it's describing the pattern to get us from one point to the next point. So if I describe the pattern to get from one to the next, it would be up 3 units over 2 units, up 3 units over 2 units, up 3 units over 2 units, okay? And so when we talk about it in terms of slope, which we'll use m for slope, all right, we just talk about it in terms of the motion up and down over the motion left and right. So for this one, it was up 3 and over 2. And that's it. That's our slope. The slope is 3 over 2. That's rise over run. It's just describing the pattern, but now we're going to write that pattern as a fraction. Okay? If I look at the next one, again, identify some points that this thing goes through. Looks like it goes through this point, this one, this one. And so again, if I'm describing the pattern, if I was describing the pattern to get from one point to the next, I'd probably say I had to go down 1 over 2. And I always go left to right like I'm reading a book. So when I look at points, I always go from a point on the left towards a point on the right. And that saves me some trouble in the long run if you always do that. But I describe the pattern, I have to go down 1 and over 2. So the difference here is if I'm going down 1, again, I mentioned this earlier, but in science, usually positive and negatives indicate a direction, all right? And it was the same thing for plotting points. Going up was like the positive direction. Going down is like the negative direction. So if I say down 1 over 2, I'm going to describe that as negative 1 over 2. That's rise over run. And see, it's interesting because it's not rise, it's actually lowering the thing. So rise, if we wanted to say, hey, we want to go down, we describe it as a negative. That negative sign is indicating the direction, okay? But again, it's still just describing that pattern. We're just going to write that pattern as a fraction now, okay? If I look at something like these guys, if I'm looking at these, see this, maybe doing, the rise over run might be tough here because we're looking at ordered pairs, all right? You could still do that and just think about like looking at the y values and saying, okay, what's the rise from -5 to 4? How far did it go up? And that's really change in y. When we talk about change in y, we're saying how did y change? And so maybe you can look at that and say, okay, from -5 to 4, it went up 9 units. All right. And then maybe looking at the x values, you're going from 4 to -2. It went down. All right. That has to go down 6 units if you want to think of it that way in terms of rise over run, and then reducing that fraction. That's actually how we use change in y over change in x. Okay. And if you're looking at that saying, yeah, I got that, Mr. Jansen, you're doing change in y over change in x, and you can do the slope that way. All right. You can look at the y's and say the y was this, now it's this. How did it change? How did it move? Did it go up or down, and how many? All right. Then look at the x values and do the same thing. Okay. And just be really careful with your positives and negatives there. The other option for us is going to be this guy. It's this slope formula where we do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm saying x sub 2. It's a subscript. It's just a label, all right? And really what this is saying, hey, take the second y value, which is 4, and subtract the first y value, which is negative 5. And now take the second x value, which is negative 2, and subtract the first x value, which is 4. And really, it's going to yield the same result. You just have to be careful. Remember, subtracting a negative, that's the same thing, adding the opposite. Always change subtraction to adding the opposite. Now it's 4 plus 5, which is 9. Down here, I can do the same thing. That's the same as adding the opposite. So that's negative 2 plus negative 4, which is a negative 6. And now reduce the fraction. That's 3 over 2. And we typically just don't write negatives in the denominator. We either stick them out front or put them with the numerator. Okay? And that's it. Notice I get the same thing. All right? So if you're looking at this thinking, I got that change in y over change x thing, Mr. Jansen. If I'm looking at a negative 2 for y and now a negative 5, think about how far it had to move and in which direction. And so if you think about that, it had to go down 3 units. That's my y value for my for the slope, okay? That's the change in y. And then look at the x's. If it was a negative 3 and now it's a 6, it went from negative 3 to 6. Think about on a number line how far you have to move, all right? And so that would be from negative 3 to 6, that would be a positive 9. So the slope this time is going to be a negative 1/3. Okay? But now let's do our formula. Ready? Second x value, or second y value minus the first y value, second x value minus the first x value. So the second y value is a negative 5 minus the negative 2. The second x value is a 6 minus the first one is minus a negative 3. Again, subtraction, you should change to adding the opposite for each of these. So now in the numerator I have negative 5 plus 2, and negative 5 plus 2 is a negative 3. In the denominator I have 6 plus 3, which is a 9, and that's a negative 1/3. Okay? And the other option here, which is probably the most cumbersome, is you could literally take some graph paper and plot those points, graph them. If you graphed those 2 points, you would be able to just do exactly what we did up here and do rise over run, okay? So you always have the option of going back to the graph, okay? If I look at these guys, again, same kind of thing. Let's take it off to the side. Let me think about change in y and change in x. Let me think about from negative 5 to 7. Think about it on a number line. How far would you have to count to get from negative 5 to 7? You would have to count up 12 units, okay? So that would be a 12. But then from 4 to 4, think about what you would have to count. You would have to count from 4 to 4, that's 0. You don't have to count any. So the slope is 12 over 0. Well, that's impossible. Remember, 0 is the one thing we can't divide by. So what we call that is we say that's undefined. And again, let me do my formula here. Let's see if I can do it without actually writing the formula this time. The second y value minus the first y value. The second x value minus the first x value. Change subtraction to adding the opposite. That's 12 over 0, which of course is impossible, so we say that this is undefined. And when you think about a line that's undefined, basically that is a vertical line. See, one of the ways that we think about slope is how steep the line is. When you think about the values describing slope, the bigger the slope is, the steeper the line is. And the smaller the slope is, the less steep the line is. And so what happens if it gets so steep we can't measure it anymore, we say it's undefined. Okay, it's too steep. All right. If I look at the next one, again, same kind of thing here. If you were to do the change in y over the change in x, if you said, hey, from 3 to 3, it doesn't move at all, so it's gone up and down 0 units. All right. To get from 3 to 3, you move 0. To get from 2 to 6, you move up 4 units. So now this is 0 divided by 4. That you can do. 0 divided by 4 is 0. All right? You can't divide by 0, but you can divide 0 by something else. All right? So keep that in mind. Students get those mixed up all the time. Divided by 0, undefined. 0 divided by something, 0. Okay? And so again, if I did my slope formula here, second y value minus the first y value, second x value minus the first x value, that's 0 over 4, which gives me 0. So the slope this time is a 0. And that's describing a horizontal line. Again, if we think about slope measuring how steep something is, if basically the thing has no steepness at all, a horizontal line has a steepness of 0. If we're measuring how steep it is, we would say 0. Just like a parked car, we would say is moving 0 miles per hour if we were measuring the speed, if it's not moving at all. If there's no slope, if there's no angle to this line, then we say the slope is 0, okay? And so if we look at these visually, okay? So visually, just getting an idea for kind of slope in general, when we look at something like this guy, we would say that this one has a positive slope because it's going up. So visually, that's what positive slope looks like. Here, this is what negative slope would look like. All right? This one would be a slope of 0. And this one would be a slope that's undefined. And furthermore, when you look at those first two, the positive versus the negative slope, notice the negative slope is steeper. That would have a higher negative value than the positive one would, okay? So like, let's say this guy had a slope of 3 over 4. This one would be negative and would have a slope that's a bigger value, like a 2, something like that. And you can tell that just by looking at how steep that line is, all right? And so that kind of generalization helps us just to kind of check our work after we use slope to plot things, okay? So rate of change compares a change in one quantity to another. So that's literally the same thing as slope. Slope is just more specific. Slope is when we compare the vertical change to the horizontal change. Rate of change is the same thing, but not necessarily vertical and horizontal, all right? Rate of change is what we call it when we're looking at a real example, all right? In science, you'll almost always think of it as rate of change. Is it the same thing as the slope? Yes, but slope is specifically comparing up and down and left and right, all right? Rate of change is a little bit more broad. It can compare any two things, all right? For example, if I look at this guy down here, it says the table shows the time and cost of renting a paddle boat. Find the rate of change in the cost with respect to time. And notice, this is time and cost. It's not X and Y. It's not up and down versus left and right. If we graphed this thing, we'd treat it like up and down and left and right, but it's just really two different values, all right? This is the values of hours, and this is the values of money. And so if you kind of think about this, and this is where we'd want to use that change Y over change in X, looking for the pattern, like here, this is going up 2 units each time, and this one is going up 7 units each time, all right? So if we think about the rate of change when we compare the cost to time, we would say the cost is changing by 7, and again, I can call it the slope. The cost is changing by 7, while at the same time, the time is changing by 2. So the rate of change is 7 over 2. However, in math, we always write slope like fractions, but that doesn't make sense anywhere other than math. Anywhere other than math, it would make more sense to plug this into a calculator and call it 3.5, all right? And the reason for that, if you think about 3.5, think about what that represents. That 3.5 represents the cost per hour, okay? And so when you think about this in terms of the units, this was the dollars, this was the hours, and notice that's dollars now per hour. When you think about any unit that you've ever heard, like miles per hour, that's describing a rate of change. It's how many miles based on how many hours. You could write it as a fraction. It's the same as slope. All right. And that's the thing we want to understand. We want to understand that this slope represents something more than just change in Y over change in X. It represents $3.50 per hour. Okay. And if we were to graph this thing, the slope that we would find, the pattern that we would find would be up 3.5 over 1, up 3.5 over 1. But what that slope is describing is the change in the cost based on the number of hours, okay? So again, slope and rate of change are the same thing. There's three ways to think about it: rise over run, there's using that formula, and there's the change in y over change in x. And we really want to think of this in context, all right? We want to give context to these things and not just think of them as x and y values, but as two values being compared, and we just stick them in a fraction, okay?